Hi guys, welcome to the session. I hope you can hear me loud and clear. Cool. I'm Gagandeep Singh. I'm a product engineer on the Runtime SDK for iOS team. So let's get started. Talk about animation. I believe all of us use so many apps every day. All of these apps contain so many animations. Some of these animations are very subtle that you don't even recognize them. For example, the view transition animations. And some of them stand out a lot. For example, some of the pull to refresh animations you see. So you get the point. The animations make a big difference in the user experience. At times, they delight the user. At times, they provide feedback or acknowledgement and helps tell a story for the user who's using the app for the first time. So in this session today, we'll be trying to bring that experience to the map animations. So let's take a look at the agenda today. So today, I'll be showing you 3 different types of animations: point, viewpoint, and polyline. In each section, I'll be starting off with a demo, showing you the fundamental aspect of the animation, and then taking you through slides, showing you how that works, and in the end, showing you some applications where you can use them. So let's get started with point animation. The most common use case, or let's just start with the demo first. Okay, cool. So the most common use case for a point animation could be an animation along a path. You have a route, you have a path, and you want to simulate a graphic along that path. So for example, this is an application, a pseudo type for a routing application where you generate a route, and then you want to simulate a car or another graphic along that polyline. I would like to highlight here how if I rerun the animation, if you look at the flow of the car, it's pretty constant. The speed is constant across the whole polyline, as I'll be talking about it in a few minutes. Another thing I'd like to share is all the demos I'll be sharing are using Swift 3.0 and the Runtime SDK 100.0 for iOS. And all the demos will be available and are public in GitHub repo. So let's switch to the slides and take a look at how this is working. Let's just start by breaking the animation into different frames. Say, consider we have a line from A to B. How would you animate a graphic along this path? So let's say the first frame is, in the first frame, you'll see the car at point A. And some frames across, it'll move towards B. And as you keep going on with the increasing frame, the point starts moving more towards B. And there comes a point when the animation is done and the car graphic is at point B. So the trend we are seeing here is for each frame, I'm trying to find out this point X along AB where I can put my graphic so that it looks like an animation. So I've written this class called PointInterpolator Class, which helps me do that. If you look at the class diagram, I have attributes from point to point, which are the starting point and the destination point. Then I specify the speed with which I want to animate. Then I'm keeping a timer in this class. So the timer is the vital part of this class. It's firing, it's generating new frames with the duration I specify. So as you know, the standard frame rate for an animation is 60 frames per second. So to simulate that, I'm using an interval of 1/60th of a second for this timer. Looking at the functions, I have the initializer, pretty basic. Then we have the start method that you can use in your class and just start the animation. What it's doing is it's scheduling the timer on the run loop. So every time the timer is called, or actually the timer is calling the update method, and in the update method we have all the logic for the vector math for actually computing that point x along AB. So this class is implementing the PointInterpolator delegate protocol, which provides a method didUpdatePoint, which is fired every time the timer comes up. Timer is fired and a new point x is generated. So the implementing class could know when it has to update the geometry of the graphic. And the second method is didStop at point. It tells you when the animation stopped or has completed. Moving on, so far we have been talking about the simple polyline, which was from point A to point B. Pretty basic. You used a simple timer and updated the location or the geometry of the graphic. But what if you have a complex polyline, a collection of points or a collection of segments? For that, you can just break the whole animation into a collection of animations, breaking them into individual A to B animations. To help with this, I have a different class, a helper class. I'm calling it AnimatedLongPath. If you look at the attribute, it has the polyline along which you want to animate the graphic. It has the animated graphic you provide, for example, the car graphic. So the class will be updating the geometry. So if you have the graphic added in the graphics overlay, it'll update its location. Then speed. As I said in the demo earlier, you can see the speed of the car is constant along the path, irrespective of if the segment is smaller or bigger. So instead of using duration, which will be like if A and B are far apart, and I want to travel in the same duration, the speed will be slower. And if the points A and B are too close, the speed would be very large compared to the previous example. So to keep a constant speed, I use the attribute speed. So for each segment, it'll be using the PointInterpolator class. It has the initializer, and then the public method start animation for you to use and start the animation. It has the internal or private method, which is handling all the logic. We'll talk about it in a minute. And then you have the stop animation. Looking at this, the private method, you can see in this method, I'm just getting, for that segment of the animation, I'm getting point 1, point 2, initializing the point interpolator, setting the delegate, and starting the animation. Now let's take a look at the delegate method itself, what you'll have to do if you're using this class. So in the didUpdate method, as I told you, it's fired every time the interpolator generates a new point. So in this method, I'm just updating the geometry of the animating graphic to the newly generated point. In the didStop at point, since this is a collection of animations, if it was the first or second animation, and it's finished, I can start with the next animation. And in case it was the last segment of the animation, I can let the delegate know that I'm done with, we have finished with the animation, and you can do whatever you want to do. So now let's take a look at the applications, how you can use this class, or in what scenarios you can use it. Whoa. Sorry about that. Technical difficulty, I guess. Whoa. Yeah, sorry about that. So the first application is the car route simulation. I'll just get started with it. So here you can see if you're a logistic company and you have so much data, like this company who has all the routes and the paths of its vehicle traveling in San Diego, and they now want to simulate the data and analyze stuff. So they can use this class and animate those the vehicles along the path. If I turn the switch, you can see I'm actually using the routes provided and simulating the cars. Now consider the same use case for flights. There's an airport which has all this route data, and they now want to look at or simulate the flights from outbound from their airport. So these are all planes flying from Heathrow Airport at different times and at different speeds. If I turn this switch on, you can see I've been provided with the paths for the flights traveling to different airports in the world. And then I'm just simulating the planes. So let's take a look at the next section, or the next type of animation, viewpoint animation. So often at times, you want to highlight some features on the map. Say, for example, you have some results from a query you want to zoom to. You have a viewshed from a geoprocessing analysis you want to zoom to, or you want to highlight some other feature on the map. You can use the viewpoint animations, like in this case, I'm zooming into London. Or you can basically just zoom in and zoom out, animating the viewpoint. And as you animate, you can see the tiles are redrawing itself. We already provide an extensive suite of APIs or classes to support viewpoint animation in our SDK. We have a class called AGS Viewpoint, which is basically a class where you can specify either center or scale. You can use center, scale, or rotation. If you have a bounding geometry or extent or just a polygon, you can use a target extent initializer. You can add rotation to that. And if you are dealing with latitudes or longitudes, you can use this initializers. So the point is, you can create an AGS viewpoint, and then use on the map view, you can use these couple of methods to animate to those viewpoints. You can use the set viewpoint with duration and completion method to zoom to that viewpoint. You can also choose the curve if you want to ease in or out of the animation. Apart from these couple of methods on map view, you can also use some of the other methods available and just completely skip the viewpoint part. You can use set viewpoint, center scale, and then with completion, you can use just change the scale and animate it. You can just rotate the viewpoint. If you have a geometry, you can use that to set the viewpoint. You can use padding with geometry if you don't want edge-to-edge geometry visible on the screen. Now let's take a look at how you can actually use this in your application. So I'm using or building on the top of the same application I used. In this application, you can see I'm animating or showing an overview of directions for a route. I'm putting a geometry or using the direction geometry and putting this orange, creating this orange direction maneuver, then setting the viewpoint to that geometry using padding with rotation along the polyline, the tail of the geometry, and then also showing direction messages on the top. Cool, isn't it? On to the final part of the presentation, the third section, polyline animation. Let's again start with a demo. So I'm calling it a draw animation. As you can see, the polyline is drawing itself with time. So you can use this type of animation for the same use cases I mentioned in point animation, where instead of simulating the graphic itself, you can simulate the polyline. Let's take a look at the slides, how I'm doing it. Let's just start by, again, breaking the animation into different parts or the storyboard, looking at the storyboard. If you look at the first frame, you might see the partial polyline being seen on the screen. As you move on with the frames, you can see more and more polyline being visible or drawn on the screen. So if you compare this to the point animation, you can see it's the same concept. I'm just looking for this point X along AB and building a new geometry and putting it on the graphic. So it's using the same PointInterpolator class I use for the other animation with all the same properties and the methods and the protocol. Again, if you want to do it for a complex polyline or a collection of points, you just have to break it into different parts and chain them together, chain the animations together. For chaining the animation, in this case, I have a helper class called Draw Animation Helper Class, which is the interface is pretty similar to the AnimatedLongPath Helper Class, but there's slight difference in the implementation only. So if you look at the interface, it has a polyline animating graphic that'll be updating. It has the speed and the interpolator. It has the same start animation you can use, methods you'll be calling, and then the stop animation if you want to stop the animation. The start animation and turn method is the same. It's just getting 2 points, point 1 and point 2 for the segment of the animation, using the interpolator, initializing the interpolator, setting the delegate, and starting the animation. The only difference for this one is in the did update point method, delegate method. In previous case, we were just updating the geometry of the graphic. In this case, when we find the point X, we consider the points, or we create a polyline builder at the points that are already drawn to the polyline, and then this new point X, that's a whole new polyline geometry. We assign that to the animating graphics geometry, and that's how the animation is done. Other than that, the stop animation is just starting the next segment of the animation. Now let's take a look at the applications. So if you consider the same flight simulation example, whoa. So earlier we were simulating the planes. Now you can simulate the routes themselves. So it's the same Heathrow Airport, the same data. Now I'm simulating the routes. I'm just using a random function to start them at different points and give them different speeds. Now for the finale, let's just combine the point and the polyline animation. So if you do that, you see the plane traveling with extending the route with themselves in the animation. And you can see how the map view is pretty interactive as I pan or zoom across the map view. To finish off, I would suggest please take the survey. It's on the iOS app. You have the Events app. It helps us prepare for the next year. And if you want the code, it's available right now on the GitHub. You can take a picture or write down the URL. There are other stuff in there, like the graphic I was generating for this turn-by-turn animation. It's using sub-polyline extension method I wrote on Polyline. So you give it the polyline and the distance in meters, and it gives you back a sub-polyline. That's how I'm generating the geometry in the middle of two direction maneuvers. Cool. Thank you guys for coming. I hope you liked the session. And if you have any questions, we can take them right now, or we are available in the showcase. You can show up and ask me any questions for animations or just about the SDK. Thank you guys.